Good morning. Welcome to the last week of lectures for this ongoing online course on Engineering or Architectural Graphics Part 2. And in the first 3 weeks of this course, we have learned how to draw isometric drawings, how to draw isometric projections for any type of object given, 3D, 2D planes, combination of solids, sections of solids or blocks. So, we have understood the fundamentals, the basics and also applied them through several problems and understood how to draw these isometric projections. Now, in this week what we are going to look at is isometric projections. Now, ideally I should have first introduced you to the axonometric projection and then gone ahead with the isometric. The reason being, isometric projection is also a type of axonometric projection. So, if you are talking about axonometric projection is a larger set of projections. And now, when you have already understood what an isometric projection is, we can also understand the characteristics of isometric projection which are actually the same as axonometric projection. Let us see what these are. So, basically what we are trying to do through isometric or axonometric is that on a two-dimensional sheet, through a two-dimensional drawing, we are trying to represent a three-dimensional object. That is what the main intent of this set of projections is, which is collectively known as axonometric projections. And the fundamentals which we had learnt, the basics of isometric projection which we had learned, they remain the same for all axonometric projections as well. So, what we mean to say is that we will assume 3 axes at certain angles. So, for isometric we were very clear that these 3 axes when seen together in a point will have equal angles of 120 degrees between them. So, all the 3 axes all the 3 planes are going to be visible in this object. We knew that from where we are viewing, so our viewing plane is actually not parallel to any of the coordinate axes. So, if you remember what we were doing, if you look at the isometric like this is the grid, this is where we were viewing it from and it was not parallel to any of the coordinate axis. So, it was at a different angle from the 3. Then we were looking at the edges of these objects as shown as being projected on the plane of viewing. So, all these edges are actually being projected on the plane of viewing, which is why we see them being parallel to the coordinate axis, but very distinct as edges here. The dimensions are foreshortened, especially in case of isometric, we see that the dimensions are foreshortened and we looked at the isometric scale. The parallel lines, they continue to remain parallel in the object. So, in the drawing. So, if the object has parallel lines, those parallel lines will continue to appear parallel in the isometric drawing of that object. If the lines are not parallel, then we would derive them with the help of parallel lines. We would draw lines which are parallel to the coordinate axis and then derive the projections of the lines which were called as non-isometric line. So, all those fundamentals, they are exactly the same, they remain the same in axonometric projection also. Now, before you get confused further, now you might be wondering that when the fundamentals, the basics, everything about isometric and axonometric remains the same, then why at all do we require to learn another set of projection system very similar, which is axonometric here. Now, to come to that, we first have to see what this axonometric projection is. Now, it is again a parallel projection technique. So, isometric is a type of axonometric. Now, axonometric is a parallel projection technique which is used to create a pictorial drawing, a 3D drawing of an object. Okay. Through orthographic, we were only looking at one of the faces of it, one plane of it which was parallel to one of the reference planes. But here we are viewing it at a certain angle from the reference planes and we are looking at this object in a 3D. Now, axonometric projection has three types of projections. One is isometric, which is what you have already seen. There is another one which is called a dimetric projection, and the third one is called a trimetric projection. All are axonometric projections only. Now, in isometric, if you remember distinctly what we do, we will make these lines, the two coordinate axes at 30 degree from a line which is horizontal to the viewing plane, okay, and the third one is perpendicular to it. So, we assumed two axes like this is the coordinate axis, and the third one going here, where the angle between the three remained equal and 120 degrees. This is what we have done in detail, we have learnt in detail, because it is easy, very easy to draw. We can look at the dimensions, we can measure the dimensions, and it looks very realistic, closest to the realistic. So, of all the axonometric projections, there are all these three different types, and there is another type which is what we are going to do in detail. Of all of these isometric projections, they look most real. They are not actually real, because if you are looking at an object, a big object from the front, probably you will not be seeing the top of that object as distinctly as we do in isometric, but still it is one of the most realistic scientific projections, okay, which can be measured back. So, that is what we get, that is the advantage of isometric projections. The other one is dimetric. In dimetric, what we have is that we have again the three coordinate axes being represented just as we did in isometric projections, and then what we have between the two axes, which is vertical and two horizontal, what we have is angles which are equal, but they are greater than 120. So, you will see whenever we have dimetric projections, the object looks little flattened. So, which is what we are seeing here. Compare this isometric with this dimetric and the views that we are getting for the same cube. We see that this appears to be a little flattened one, and here the third angle automatically will become greater than 120. So, the most common dimetric projection which you will find is where we have this angle being 15 degrees. That is what we will have, and then you can derive all these angles. This is what you will commonly get, but it is not a very commonly used axonometric projection. The third one is a trimetric projection, where none of these angles is equal. So, we have three angles, they are all different. This angle is not equal to this angle, and it will make us feel that one of the axes is elongated, okay. So, by virtue of this, this is a trimetric projection. Now, all these are axonometric projections. The fundamentals, the basics which we have learnt, they remain the same, exactly the same. We use them in different circumstances, different contexts, depending upon what is the object that is being viewed. Now, the fourth one which I was talking to you is also known as military projection, and this is again a type of axonometric projection. Okay. This is the one, this military projection is the one which we use commonly in architecture, especially when we have larger plans to draw, say maps or community drawings. When we have such large plans, this military projection, and commonly we know is that it as axonometric projection. It is a wrongful understanding of that. Yes, right in the sense that military projection is also an axonometric projection, but wrong in the sense that we call it as axonometric projection, because axonometric projection is a larger set, and here we are using this military projection. But for the ease of understanding and to make you more familiar with how we use these terms in practice, we will use it as axonometric projection only. But I want you to understand that this is not the only way in which axonometric drawings could be made, or this is not the only way of drawing axonometric projections. Okay. So, we have isometric, dimetric, trimetric, and we have this military projection as well. Now, what are we doing here? We are following the same rules, exactly the same rules with slight changes. So, we have the fundamental rules, all parallel lines in the space are shown as parallel. Another thing that we use the true dimensions of the plan and section here. Unlike isometric, dimetric or trimetric, where we could be using, or rather we should have been using the isometric scale. Here we are not going to be using isometric scale. Okay, we will be using the true dimensions of plan, section, the heights, everything in true dimensions, and it becomes very easy to draw. And again the same, all the 3 dimensions are shown at the same scale, just as we did in isometric projections. So, what are we doing in this military projection, or which I am going to refer to as axonometric projection henceforth? So, what we have is that these angles are 45. The moment we make these angles, these axes at 45 degrees from the reference, this plane of viewing, we get this angle as 90, or rather I should have drawn it as this. So, this is 90, and then we just project the third axis, which is the vertical axis, which is actually the height of whatever object we are drawing, and we get a very realistic drawing, a 3D drawing without putting in much effort. Now, you will say, how is it that we are not putting in as much of effort? Now, as I said that we use it more for architectural purposes, especially when we have bigger plans. For example, this is a large campus, as what you can see on this screen is a larger campus. When we draw the site plan, so if you are familiar with these terminologies, if you look at the site plan and you get the blocks of these buildings, and I want to see how would the site plan from the sky would look like, this is what I will get. What I have to do is rotate this plan. So, generally when we have these buildings at right angles, so the walls are at right angles, the most commonly used shapes are rectangles and squares. What we are doing simply is, instead of looking it straight, we are rotating it by 45 degree. We do not have to redo the plan. Okay? We just do not have to redo the plan, we just have to look at the plan at an inclination of 45 degrees. The plan is now rotated and the vertical axis remains the same. So, if you look at this, this is the plan which is given as a site plan, part of the site plan. Okay. What we have is do nothing. If originally if the sheet was being seen, this probably would have been the sheet. This was the orientation of it. So, we would be seeing this plan being aligned with the orientation of the sheet. Now, if I have to look at it in axonometric, all we are doing is forget about the sheet, rotate the plan 45 degrees, which is what we are seeing. So, now our sheet is this. Okay. So, we have already rotated the plan, and all we are doing is we are giving it the height, the desired height, whatever is proposed. So, whatever this height h is, we just take it for a different, for another building here on the same site plan, we see it is a different height, here it is a different height, here it is a different height, and we just give it a certain height, and automatically what we have arrived at is a 3D view, a tentative 3D view of this entire site plan, which otherwise would have taken us a little while. If we were doing isometric and we were to draw the same thing, what we would have done is we would have drawn it all over again in 30-30, this axis, right. The same plan would be drawn all over again, we would measure the dimensions and do it. Here what we have done is whatever plan we have, we just rotate it by 45 degrees and we start making it. It becomes little tricky. It is exactly, the procedure remains the same as isometric, but it becomes little tricky when the walls are not vertical, when the object is not straight, it is inclined. In that case, we will have to derive it just like we did for isometric drawings. But whenever we have plans of all regular buildings largely across the world, we will find that the buildings are straight, they are upright, they do not incline as much unless it is a monument of iconic nature. All we would be doing is incline the plan by 45 degrees and extrude it, project the height, give it certain height. So, if you look at this example, I will just give you an example here. So, what we have is there was a plan. Okay. So, this is the plan which we have rotated in at a 45 angle. So, we have just rotated this remains 90, the plan remains exactly the same. Okay. So, we have all this. Now, what we will start drawing is we will start projecting the topmost ones. Okay. So, what we have is, okay, this has a height of 5 units. So, we extruded them first. In the next step, we have other objects, say this one and this one here, which is having a height of 3 units. Then other parts. So, this part 2 and the 2 parts here, and the remaining parts having the height of 1. And now, same way as we did isometrics. So, we are not drawing the hidden lines here, but we just complete the entire object, and what we would get is this entire thing. Okay. So, this is how we would see an axonometric in very simple terms. So, we usually commonly, especially when we have lesser time and or if we are not intending to show too much of detail, but we want to present how it will look, a perception of it, we go with axonometric drawings, especially in architecture or when maps or large scale drawings are being done. This is an example of how do we do that. This is for a small residence, an apartment. So, we did the plan. Okay. This is a detailed plan. We can see the walls, the windows. So, these are the windows, the doors coming here, window again, thin walls, partition walls, whatever. Now, all we have to do is we have just rotated this. Okay. So, what we have done here to get an axono is we have rotated it by 45 degrees, same plan. Now, it depends upon you what is the object of interest, what is it that we want to show. So, we could have drawn it the other way around like this, we could have rotated it this by this point, or here we have rotated it about this point in the anti-clockwise direction. It is totally up to you in which direction do you want to rotate it, depending upon what is the object of interest which you want to see. So, some part will actually go behind, they will be hidden. So, what is it that we want to hide is will decide that which direction do you want to orient it to. It does not matter, it totally is the architect's or engineer's choice which direction does he want to rotate it to. Once we have done that, then all we are doing is providing it the height, extruding it. So, if you look at the walls here, so if I draw it from the rear one, here you can see. So, there is a shadow of the same plan which you can see. So, which is what we have done, we have taken here just to tell you that how this is going to come. Suppose this is 3 and there will be another line in front of it. Now, look at this and this. So, if you look at this, we will actually have the height of the wall which is coming here. Okay. The same thing we will do here. This is what we are getting. Now, here for the balcony it is very thin. I am just now how are we getting it is by extruding. I am just making these vertical lines here, but this balcony which is apparently this is a railing. So, this is not going to be this high. What we are going to do here is not take it at this height, but take it at whatever height we are looking at and which is also here, and everything else remains parallel. So, this is the railing that we will be looking at, right. Again the wall here goes up, it is a say 3 meter height, and there appears to be a window. So, wherever whatever height that window is at is what you will be drawing and noting here. So, this becomes your window. Okay. Take it again, height here. So, it is not very clear that what do we have here, but probably we have say a sliding door or something like that here, which is what you will draw. And we can then also give the heights to these furnitures. So, we can extrude the furniture. If you want to do it in detail, you can extrude the furniture also. This is like an office desk. Okay. All you have to do is keep drawing and extruding the entire thing. So, the office desk, you can actually arrive at the entire thing here. This is for your bathroom. Now, some things here will become evident, visible, and certain things will not. So, we can also, so this is what we are looking at when we are seeing here. Now, all of this, given the height that these fixtures will have in the bathroom, they will not be visible. So, what we can actually do also is that I can assume it to be cut like this if there is a significant detail which we want to show. So, once I cut this section, this partition will go. So, we would not have this partition. Okay. This is our choice and it is very easy to do that here. And now I can extrude. Suppose I have a detail for the wash basin. There is a specific type of wash basin which needs to be represented here. We can do that. So, we show these details, whatever details are coming our way. We could show the details of the doors, windows, everything. The only thing being, and it is very easy to just extrude this entire thing to whatever height you are taking, whatever height you are assuming. If there is a low wall or low height wall, or if there are partitions, thickness of the partitions, the details, everything can very conveniently come onto this axonometric. That is why it is commonly used for doing architectural plans and maps and bigger site level plans, especially for site level plans, because there we do not need to draw as much details, and it is one of the most convenient ways to represent, to communicate the idea through a three-dimensional object. So, I hope you understand the difference between the isometric drawing and this military drawing, which we are understanding as axonometric henceforth. All these are axonometric projections only, they are types of axonometric projections, but their usage varies slightly. So, depending upon that, for architectural purposes, for plans, for extruding the plans, for showing the plans in 3D and understanding the architectural drawings, axonometric drawing or military drawing is what we are going to be using. So, I will close my lecture here today, and in subsequent lectures of this week, we will see quickly, very fast, how do we go about drawing axonometric drawings. The fundamentals remain exactly the same as your isometric drawings. So, we would be going very fast over them. I hope you will keep pace, and I am hoping that you are understanding all that we are discussing here. In case you have any query, any problem, you can write back to us with your queries and we will try to solve them as much as possible. Thank you very much and have a great day. Bye-bye.